you know how to represent a vector. When you take a vector, we'll represent it like v1i plus v2j plus v3k. So this is how we represent a vector in 3 dimensions. So first of all, you should know about dot product and cross product. And dot product is called a scalar product, whereas the cross product is called a vector product. Why? Because result of a dot product is a scalar, so that is why it is called as a scalar product. And here, when it comes to the result, it gives you a vector, so that is why it is called vector product. So dot product, geometrically, you can see how it is defined. You can see it like a projection of one vector on another vector and multiplying with its length. Whereas numerically, let's say if it is v1, v is this, and let me assume u bar is, and you know how to write v dot u, that is component wise multiplication, which is nothing but v1 into u1 plus v2 into u2 plus u3 into v. So this is a scalar. Whereas when it comes to the cross product, v bar cross u bar, so the resultant, you know how to calculate I times the determinant of this matrix, which is v2, v3, u2, u3, minus j into determinant of this matrix, which is v1, u1, v3, u3, and similarly plus k. So the dot product is commutative. It means u dot v, which is same as v dot u, but whereas the cross product is not commutative. So this is commutative, but cross product is not commutative. Why? Because v cross u, which is equal to minus of u cross v. And of course, you can see what is this cross product geometrically. Geometrically, let's say if I take two vectors u and v, okay, when I take the cross product of these two, so this will give you the resultant vector which is perpendicular to both of them. So this is what exactly u cross v. It is simply, you know that right hand rule, right? So when you rotate it, the resultant will be upwards when you rotate it in an anti-clockwise direction. Whereas when you rotate it in a clockwise direction, the resultant will be downwards. It means in one direction you get upward vector, and another direction you get a downward vector. So upward, let us take it as positive, downward, let us take it as negative. So when you take v cross u, so you will get upward, this is v cross u, okay, v cross u. Whereas the downward one is nothing but u cross v. That's what negative of whatever you have seen earlier. So cross product is not commutative, whereas dot product is commutative. And there is another product which is called the box product. Let's say if I have u dot product with v cross product, and this is what exactly we call the box product of u, v, and w. Okay, it is same as taking the determinant of this matrix. Okay, so this will exactly give us, this will give us a scalar. This scalar quantity represents volume of the rectangular box, which is given by u, v, and w. It means given three vectors, you can create a rectangular box. So take this box product, which will give you the volume of the rectangular box. Okay, so these are the basic products you have: the dot product, cross product, and the box product. So next thing you should know about the operators. The operators are differential operator. That's what we call the gradient operator. You have a function. It is a function of three variables. Let's assume x, y, z. W equal to function of x, y, z. Now I'd like to see its derivative in one particular direction. Suppose if you have some surface here and you'd like to know its derivative, the rate of change of the surface in particular direction. It means x of t is given, x of t, y of t, z of t are given. In that case, you can see how to take its derivative. dw by dt. Using chain rule, you can say that this is dou f by dou x into dx by dt plus dou f by dou y into dy by dt. Similarly the other. Now this one you can write it as dot product of two expressions. One expression is this, dou f by dou x I plus. So you can see this as a dot product of these two expressions. Now this vector, if you observe, which is exactly tangent vector to the given vector, dx by dt, dy by dt, dz by dt, which represents tangent vector to the given vector. Anyway, so if you want to know the rate of change of this function, so first you take this guy, this vector, dot product with the tangent vector. It means whatever direction, in which direction you want the rate of change. So you take the direction vector. That direction vector here is nothing but tangent vector. So tangent vector dot product with this will give you rate of change of this function. And this is how we are going to find the directional derivative of a function. If you want directional derivative of a function in a particular direction, you take this guy, whatever you have it here, and you take the dot product with the direction. This one can be rewritten like this, dou by dou x I plus dou by dou y j plus dou by dou z k, which is acting on f. It is same as this, right? Now you found an operator here. So the operator is this, and we are going to denote this operator with this notation. Okay. One can call this as a gradient operator or the derivative operator. We can call it simply as a derivative operator. Why? Because which gives you the derivative in each direction. So if you want a derivative in a particular direction u, so now the derivative is nothing but you take del acting on f dot product with the direction. So this will give you the direction derivative. Now remember, this is an operator. It is not. It is just an expression, and it is an operator. And here, let me write what is del square operator. It is nothing but del dot del. Why? Because these are this is in a vector form. I can take the dot product. So dot product of this with this is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square. And this is what we call Laplace operator. Okay. Now let us see what is the action of this operator on a scalar field and as well as on the vector field. Now if you take del acting on f, this is what we are going to write gradient. Okay. Grad f, which is nothing but this is how the gradient of a function is defined. Gradient of a scalar function. To understand this, let us look at a problem. Let's say gradient of, we're asked to find 2xy plus z square plus 1. So what do? First you differentiate this with respect to x. The result is 2y into I. Next differentiate it with respect to y, which is 2x into j. Next you differentiate this with respect to z, which is 2z into q. So this is the gradient of this function. Let us look at one more example. Let's say del acting on 2xy plus xz plus yz. Now derivative of this with respect to x is 2y plus z into I. Next derivative of this with respect to y, which is 2x plus z into j plus derivative with respect to z, which is x plus y. Okay. So this is how we calculate gradient of a scalar. The next thing, let us see what is the action of this operator on a vector field. So there are two vector operations we know. One is the dot product and another is the cross product. So first let us look at the dot product, that is del dot product with a vector field. So now I need to deal with a vector field. So let me mention, let's say f bar of x, y, z, where f1, f2, f3 are functions of x, y, z. Okay. Now let us see what is the action of this del dot product with f bar, and this is what we call divergence of f bar. Why? Because physically it has a significance, it shows something. when you draw a circle in a vector field, this exactly denotes like the amount of vectors which are going out of the circle. So here is the vector field. This is actually the vector field of F equal to xi plus yj. When you draw this vector field, this is how you can see the field. Now you draw a small circle here, and you see the number of vectors coming in and going out. You look at the magnitude of the vectors. So coming in and going out. Let me draw a big circle to understand it better. You see, while entering the vector, you look at its magnitude, it is less, whereas while leaving, it is more. Now you have a positive divergence here. Whereas if it is reverse, like say while entering you have more length and while going if you have less magnitude, then you can say that is a negative divergence. But anyway, here it has a positive divergence, and let me write how it is defined. The dot product of this and this, which is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. This is how the divergence can be calculated. See, the derivative of first one with respect to x, second one with y, third one with z, and you need to add them. Remember, dot product will give us a scalar, so you should not write I, j, k, e. Okay, so for this vector field, let me write it as divergence of f. Now for this vector field, if I take f bar equal to xi plus yj, then the divergence of f, we denote it as div. That's equal to dou by dou x of x plus dou by dou y of y. So this will give you 1 plus 1, which is 2. So the divergence is 2. It has a positive divergence. That is why you can see this is what happens. And you can have some vector fields which do not have divergence. It means the divergence is 0. Let me give you one example for that. So here is a vector field which is given by f bar equal to yi minus xj. And if you look at the divergence of this vector field, divergence of f bar, which is nothing but dou by dou x of the first element is y plus dou by dou y of the second element is negative x. You know its derivative is 0 plus its derivative is 0, so finally it's 0. So the divergence is 0. Of course, you can see that by taking a small circle here. Okay. See, you can see it this way. It need not to be, see, entering into the circle. You can take it from this direction. So this is what divergence. And let me tell you, if the divergence of the vector field is 0, we call that is incompressible vector field. If divergence of f bar equal to 0, then f bar is called incompressible or solenoid. So we say a vector field is incompressible or solenoidal when its divergence is 0. You can understand why it is called incompressible. Why? Because you can see the divergence is 0. And I hope you can understand it from this, like when there is no change in the magnitude of the vector's flow, then it cannot be compressible, right? So many times they ask questions on these two, like incompressible and solenoid. So we say it is incompressible or solenoidal when the divergence is 0. Either you write divergence of f bar equal to 0 or you write del dot f bar equal to 0. Both are same. Okay. So therefore, whatever vector field you are seeing on the board, which is an incompressible vector field. And the next thing, let's see operation of this operator with respect to the cross product. That is what del cross f bar. And let me know if you have any questions or doubts. Like if you have questions, you please stop me and ask. Okay. Now del cross f, you know how to take the cross product. That's what I, j, k, and here dou by dou x, dou by dou y, dou by dou z. That is what the del operator. And we are going to write f1, f2 and f3 here. Now we are going to call it as curl of a vector field. Curl f bar, which is denoted as del cross F. And this will give you a vector. Okay, so the resultant is a vector. Now, geometrically, if you see, let me take this vector field itself. Suppose if I keep a particle in a vector field, now this curl will tell me at what speed this object is rotating around itself. Suppose if it is rotating in an anti-clockwise direction with some certain speed, then the curl is positive. That speed will be given by the magnitude of that. And the vector what you're getting here will give you the resultant vector. So, because when it is rotated around itself, the resultant will be upward or downward. It depends on the rotation, isn't it? See, for example, you can take whirlpool example. So when some rotation happens, the things will be taken down, isn't it? So the resultant is going down. See, here you can see an image. I took it from Google. Okay, so some whirlpool happened here, and here you can see how the resultant works. Okay. So now if I keep an object here, what is the chance? It's not that I'm looking at this rotation. I'm actually looking at the rotation of this guy around itself. So this is what we are looking at. And it can be understood well from the graphics of GeoGebra. You see, this is the vector field. And the curl of this vector field is 2.2. And you can see how it rotates. The divergence is 0. And if you see that everywhere the curl is 0, and of course, everywhere the curl is 0. It means if you keep an object in this vector field, it is going to be rotated around itself with some certain speed. The speed is 2.2. That's what I can see. They said curl equal to 2.2. You may say that, sir, curl is a vector. Yes, curl is a vector only. What they gave here is the magnitude of the curl. Okay, so the resultant of this guy is going to be a vector which is perpendicular to this vector field. That's what you can see. And this is what you have seen here. When it rotates, the resultant, and you can see how it happens. Whereas if you change the direction, it goes in a different way. Okay. See, sometimes water used to go up. In that case, you can see that the direction of rotation. You can see whether it rotates in anti-clockwise or clockwise rotation. Okay. So this is what about curl of a vector field. And suppose if the curl is 0, if a curl of a vector field is 0, then we call that vector field is irrotational. Or we have another name for it, that is conservative. Right now, it is good to take irrotational only, but conservative, the definition is different. For a conservative vector field, we know the curl is 0. If curl is 0, that becomes conservative. So the conservative definition is different. Anyway, this is it's not a regular class. This is just for gate. So that's why let me mention here. Curl F is 0. You can either call it as irrotational or conservative. So this vector field is not conservative. You can see that the curl is not 0 here. Whereas if you take the earlier vector field, like F bar equal to xi plus yj, this vector field is irrotational. Because you can see the curl of this vector field, curl F bar, becomes 0. Either you write curl F or del cross F. Anything is fine. This is 0. Therefore, this vector field is irrotational. Now, there will be many questions on conservative vector fields or irrotational vector fields. And there is a strong relation between the line integrals and this conservative vector fields. Whenever you come with a line integral, if the vector field is conservative, our life is very, very easy. Okay, for this, let me define what is a conservative vector field first. I hope you understood what is curl, what is divergence, and what is gradient. These three are very, very important operations. gradient, which is on a scalar field, divergence, which is dot product with a vector field, and curl, which is cross product with a vector. And there is a strong relation between these three things: gradient, curl, and gradient, divergence, and curl. So one relation is this: curl of a gradient is always 0. Means curl grad phi, which is always 0. And there is another thing, which is divergence of curl. Divergence of curl F bar, which is always 0. Okay, so these two things are true for any phi and any F bar. Whatever vector field you start with, so divergence of curl F bar is always 0, and similarly curl of grad phi is always 0. So let's define what is a conservative vector field. So vector field F bar is said to be conservative if it is given by gradient of a scalar function. When I say a scalar function, I'll assume this to be a nice function. Nice function I mean whose partial derivatives exist and which is continuous as well. Nice I mean this is what it is continuous and as well as the partial derivatives exist. That is, we say F bar is conservative if there exists a scalar function, that is f of x, y, z, such that the gradient of f will be our F bar. So you can see some examples. You see F bar equal to, let's say, 2xi plus 2yj plus 3z square plus 1 into k. If you observe that this is a conservative vector field. Why? Because I can see this as a gradient of x square plus y square plus z cube plus z. So you can see F bar as a gradient of this type, gradient of x square plus y square plus z cube plus z. So this implies I can say that F bar is conservative. Okay. So the main important thing is, if it is conservative, how to obtain the scalar function. This is very, very important. Knowing a vector field is conservative, how to obtain the corresponding scalar function. So let us see how to obtain it. And before that, let me give you one more example. So this time I'll go reverse. I'll start with a scalar function. You may take it as f of xyz or phi of xyz. It doesn't matter. Let me write some random function xyz plus x square y plus z cube into y plus 2y. So this time I'm starting with a function. From this, I'd like to write a conservative vector. So to write a conservative vector field, what do? F bar equal to gradient of f. So now it is enough to write gradient of this function. So first I have to write derivative of f with respect to x into I plus derivative of f with respect to y into j plus derivative of f with respect to z into k. Let me write it. So what is its derivative with respect to x? yz plus 2xy. That's it. Why? Because these two terms only involves x. And the rest of the term, they are not involving x. So we treat them as a constant. Okay. Now what is the constant? While you differentiate this, a function of yz is going to be a constant. Okay. So when you integrate the first expression in f bar, you will exactly get the part of the function which involves x. That's it. The rest of them, you may obtain it as 0. Okay, you will understand what I mean maybe after some time. This plus, what is derivative of f with respect to y? Now this term, and okay, all terms involves y. So which is nothing but xz plus x square plus z cube plus 2 into j cap plus the derivative of f with respect to z. Only two terms involve z. So its derivative with respect to z is xy plus 3z square y. Okay. So this is what f bar. Now you see we obtain f bar from f. Now let us do one thing. Let us see how to obtain f bar from f. Sorry, how to obtain small f from vector f bar. See, when f bar is conservative, we know this expression is equal to derivative of small f with respect to x. Therefore, let me write derivative of f with respect to x is the first expression here, which is yz plus 2xy. Whereas derivative of f with respect to y, that is the component of j, which is xz plus x square plus z cube plus 2. Derivative of f with respect to z, which is, what is it? xy plus 3z square y. Okay. Now you do one thing, you integrate with respect to x. So the first expression here, when you integrate with respect to x, just for clarity I'll write it for it, and later I'll write it directly. So integration of yz plus 2xy with respect to x plus, you need to write a constant, right? The integration constant. Maybe I'll write it later on. So now this is equal to, I get xyz plus x square into y. This is the integration with respect to x. Plus, I need to write a constant. That is integration constant. But here, integration constant is a function of y comma z. Why? Because I am integrating with respect to x only. So we treat y and z as constant. So this constant can involve a function of yz. And I know what is that function of yz exactly. Because I know what is the function. Okay. Now the first expression will give you the terms which involves x. Next, let me take the second expression. Integrate this with respect to y. So from this f of x, y, z is equal to, I am directly writing it, okay, integrate with respect to y. So I get here x, y, z plus y into x square plus y into z cube plus 2y plus k2. Now the constant is a function of xz. There is no function of xz here, so that is why you do not find. Now this implies integrate this with respect to z. When you do that, you get xyz plus, what is it here? Z cube into y plus, this is a function of x comma y. Okay. Now you can finally tell what is f of x comma y. And remember one thing, this xyz, the term, it will come here, it will come here, and it will come here. Why? Because that expression involves both x, y, z. Kabatti manaki 3 places lo adi appear avutundi. But we should consider only once. Okay. So finally when you write f of x, y, z, avi repeat aina kani okkasari consider cheyali. X, y, z. That is one term plus. Next, ఇక్కడ x square into y ఉంది, ఇక్కడ y ఇన్వాల్వ్ అయింది కాబట్టి దీనికి రిలేటెడ్ టర్మ్ ఇక్కడ కూడా వస్తుంది. ఓకే, సో ప్లస్ x square y. Next, that's it. We are done with the first expression. Next, the second expression, yz cube is here, yz cube is here. You write it once, z cube y plus 2y. 2y is only here, okay, 2y. ఓన్లీ y టర్మ్ కాబట్టి ఇక్కడ ఒకటే వస్తుందండి, మిగతా చోట్ల అది అపేర్ అవ్వదు. ఎందుకంటే 2y అనేది ఇక్కడేమో కాన్స్టెంట్ లోకి వెళ్ళిపోతుంది, ఇక్కడ కూడా కాన్స్టెంట్ లోకి వెళ్ళిపోతుంది. ఓకే, సో దేర్ ఫోర్ దిస్ ఇస్ ద ఫంక్షన్. బట్ when it comes to an objective exam, you should minimize the process. But if you want to minimize the process, definitely you should do some work on it. Let me tell you how. See here, I am finding the terms y into z. Okay. So if you have y into z, then the corresponding term, it must be here and as well as here. Y ఉంది కాబట్టి ఇక్కడ కూడా ఉంటుంది. దీన్ని xyz దీన్ని ఇంటిగ్రేట్ చేస్తే xyz వస్తుంది. విత్ రెస్పెక్ట్ టు y డిఫరెన్షియేట్ చేస్తే xz వస్తుంది. సో xz ఇక్కడ ఉండాలి. yes. సిమిలర్లీ ఇక్కడ 2xy ఉందండి. సో ఇక్కడ y ఉంది కాబట్టి దీనికి రిలేటెడ్ టర్మ్ ఇక్కడ ఉండాల్సింది. సో దీన్ని విత్ రెస్పెక్ట్ x ఇంటిగ్రేట్ చేస్తే x²y. And when you differentiate it with respect to y, you'll get x². Yes, I have it here. Okay, to understand it better, we should construct conservative vector fields. We should write some examples of conservative vector fields. From that, you can easily identify whether it is conservative or not. And of course, you can easily derive what is the scalar function. Okay, let me construct some example. F bar of xyz equal to, I'll do one thing. I'll write the first term, the component of I, randomly. And accordingly, I'll construct the ith coefficient and similarly the kth coefficient. So the first term, I'd like to take, let's say, xy. I'd like to take this plus. And you tell me the next term. Any random guy. YZ, okay. XY plus YZ. Anything else you want to give? Someone else?
X² Z².
You're saying x² Z. Y very difficult terms. Okay, simply you can have like y plus x. These terms, right? Into I bar. Let me write into I. Plus, so the next term, if you want this to be conservative, definitely this guy depends on the first term. You need to take care of the terms which involves y in the first expression. This term involves y, the next term, this guy involves y, and here is y. Now I need to write the corresponding terms here. See, when you integrate the first guy with x, I get x² by 2 into y. So when you differentiate with respect to y, you get x² by 2. So therefore I should have x² by 2 if you want this to be conservative. Plus, next I have y into z. When you integrate with respect to x, you get a xyz. So when you differentiate with y, you will get xz. Therefore I should have x into z here. Plus, next I have y here. So let me write y. When I integrate with respect to x, I get x into y. Now what is its derivative with respect to y? That is x. So I get x. Okay. So now this takes care of all terms which came here. And next, if you want to write few more terms, you can write some terms which involves only y and z. Okay, so let me write some term which involves y and z. So let me write 2y plus j into j. Next, plus. So what are the terms in the kth coefficient? So this time you need to identify what are the terms which involves z in the first expression and as well as in the second expression. First, let me take care of the first expression. Z is here and z is here. Now let me write the corresponding terms. Y into z. When you integrate with respect to x, you get xyz. Another one is x² into z. When you integrate with respect to x, you get x cubed by 3 into z. Now you have to differentiate this guy with respect to z. So the resultant term is xy for the first one, plus next one is x cubed by 3. Okay, plus, okay, we are done with x. Next, let us come to the second guy. So what are the terms which involve z here? X into z and into z. See, here you have x into z, and when you integrate it, you get y xz, and its derivative is with respect to z is xy. We anyway have it here, so no need of writing it again. Okay, since it involves both y and z, the corresponding term will be here and here as well. ఒకసారి రాస్తే చాలమ్మా, 2 times రాయనవసరం. Okay, so I don't worry about this term. Why? Because it involves x. ఇక్కడ x ఉందంటే ఆల్రెడీ మనం దీని గురించి మాట్లాడేసి ఫస్ట్ టర్మ్. సో ఓన్లీ z ఉన్నాయి చూడండి, ఓన్లీ z ఉన్నాయి ఉంది, ఇది ఒకటే z కానీ జస్ట్ y into z కానీ. So I have just z here. Integration of z with respect to y is y into z. So its derivative is with respect to z is y. Therefore, I should write plus. Now you write any term which do not involve x and y. ఎందుకంటే x and y గురించి మనం కేర్ తీసేసుకుంటాం. So maximum you can write the terms in terms of z only. Z are constant terms. Okay, let me write 2z plus 1 into 2. So definitely this vector field is going to be conservative. F bar is conservative. If you ask me what is a scalar function, I'm sure that f bar will be given by some gradient of scalar function. If you ask me what is the scalar function, I'm going to write it directly. So from the first term, you can see that is x square y by 2 plus the next term, which is x y z, plus the next term, which is x cube z by 3, plus the next term is xy, next term is x square by 2. Okay. Now here, no need of writing this term. Why? Because we wrote it here, x square y by 2. Now you do one thing. You look at the terms which are free from x here. So this is not free from x, this is not free from x, this is not free from x. Yeah, these two terms are free from x. So now let me write its derivative with respect to y. So when I write it plus, this gives me y square plus yz. Next, when you come to the last expression, you look at the terms which are free from both x and y. This is not free from x and y, this is not. Only these two terms are free from x and y. So this plus z square plus j. That's it. So this is the scalar function whose gradient is exactly whatever we have written above. Okay, I started with a big function, but in the exam you may not have this much big functions. You'll have very simple and easy functions. There you can easily see what is the conservative and what is the corresponding scalar function. I suggest you to write your own functions or own vector field which becomes conservative. Okay, you can start with any random I component, or you can why to start with only I? Yes, you can start with k as well. At the coefficient of k, you take it as any random function, and from that you try to construct ith component and jth component. Okay, and let me check whether you understand this or not. Let us see if I take f bar equal to y plus 2xz plus 3x cube into I. Plus, can you tell me what is the component of j and the component of k, so that this function becomes conservative? Whether you add extra terms or not, it doesn't matter to me. You just give me a function, you give me a vector field whose ith component is this, and you give me the jth component and kth component, so that it becomes conservative. xj plus x squared k. So our friend says this must be x. X is enough here, and here x squared. Exactly. Why? Because here you have y. So now I need to have a term which is related to this guy. So that must be x. X into y. It will give me y here and x here. And here I have z. So now I have to write the corresponding term here. You integrate with x. That will give you x squared z. Now when you differentiate with z, you get x squared. So therefore, here if you ask me what is the function f of x by z, which is nothing but x into y plus x squared z plus x cubed. Okay. Now I'll do one thing. I'll add some extra terms. Here xj plus x squared k is enough. But now here I would like to add one more term. I would like to add z here plus 1. Now this time I fix I, add component, j component. Now you should tell me what is the k component. Tell me. It means I added some extra terms here. What is it? K term will be added. It means you are saying that y will be added here, right? Y plus x squared. Why? Because you have z, and when you integrate with y, you will get yz. So when you differentiate with z, you will get y. So this is 1. So now here, y into z plus, and here is 1. Related to 1, you will have y. And if you want to add any term which involves only z or constant, that is fine. You can add, no issues. Okay. So now f bar is conservative. This is the corresponding vector. The scalar. Now we have an if and only if condition for a conservative vector field. This is the condition. F bar is conservative if and only if curl F bar equal to 0. If curl F bar is 0, then it is conservative. If it is conservative, then curl F bar is 0. In both ways, it is true. Okay. But remember one thing, every time, no need of checking curl F bar. The simple observation will tell you whether it is conservative or not. For example, do not calculate curl and tell me whether it is conservative or not. Just by observation or just by inspection, you tell me whether it is conservative or not. I'll give you xy plus 2xy plus y plus z plus 5x I plus here I give you x square plus x plus 1 into j plus here I'll take z plus y plus